Good afternoon. This one is topic intermolecular forces, which is related to Unit 2. So in this session, we'll discuss questions related to intermolecular forces, which are dipole-dipole forces, dipole-induced dipole forces, and hydrogen bonds. So in the first one, in question number 1, which compounds are arranged in order of decreasing boiling point? So about the boiling point increases as the number of the atoms or number of electron in the system increases. Or electron. So when we have more electrons, it will have a higher boiling point, or greater number of atoms, higher boiling point. And the boiling point decrease as number of branches increase. So boiling point is inversely proportional to number of the branches greater the number of branches, because when more branches, surface area is less. So it is inversely proportional to number of the branches, and it is directly proportional to number of atoms. So now we will compare which one will have the highest boiling point. So for this comparison, we have to check the number of atoms. Here we have 4 carbon atoms, we have 5 carbon atoms, and we have 6 carbon atoms. In the question, they are asking which compounds are arranged in order of decreasing boiling point. So here the number of atoms are increasing, so this is arrangement in terms of increasing the boiling point. Like the first one will have a lower boiling point than the second, and second one will have a lower boiling point than the third one. When we check 1, 2, 3, 4, 5, 6, so 6 are there. Then this one is a branch. One total are 6, but this one branch is there, and this is having 2 branches. So 6, 6, but this will have 1 branch, and this will have 2 branches. So the boiling point of this one will be higher compared to the other one and the second one, and that will be higher compared to that of the third one. So that's why B is the right answer. Is it clear? Discussion? Next question, question 2. Because this is intermolecular forces, so most of the questions are related to comparing the boiling and the melting points of a substance, as it depends on the intermolecular forces or force between the molecules. So how do the boiling temperature of ethanol and chloroethane compare, and what is the reason for that? So when we compare the boiling temperature of ethanol with chloroethane, so in ethanol, when we draw the structure, so this is eth, 2 carbon atoms are there, eth, single bond between them, and because of OH group, this is all. And when hydrogen is bonded with most electronegative elements such as fluorine, oxygen, and nitrogen, then it will form a hydrogen bond. Because to form a hydrogen bond, it should be a most electronegative element and with a lone pair. So this oxygen is having a lone pair, and this will form a hydrogen bond, and hydrogen bonds are strong bonds. When we compare chloroethane, this is chloroethane. This will have dipole-dipole force. Why? Because chlorine is more electronegative than carbon. So there will be partial positive and negative. So As you can see, hydrogen bonds are there, so that is stronger as compared to dipole forces. So the higher boiling temperature will be ethanol, and the reason because ethanol molecules will form hydrogen bonds which are stronger than dipole forces. The next question, this question is about the trends in the periodic table, the boiling temperature of some isoelectronic. Isoelectronic means they will have the same number of electrons, that's why we call them as isoelectronic. Explain the difference in the boiling temperature. So you can see CH4, then NH3 is higher than H2O, and then HF. H2O is having the highest, these temperatures are given in Kelvin. Explain the difference in the boiling temperature by considering all the intermolecular forces. Detailed description of intermolecular forces involved are not required. Like, you don't have to mention how these forces arise, but you should be able to explain the difference in the intermolecular forces caused the boiling temperature, and it's of 6 marks. So first thing, methane CH4 is having the, it does not have permanent dipole, it has dipole induced dipole forces or instantaneous dipole or London dispersion forces, which are weaker compared to hydrogen bonds and NH3, H2O and HF. So they all have hydrogen bond, but that hydrogen bonds are stronger compared to dipole induced dipole forces in methane. That's the first point. Like explaining the type of the forces which are present. So when you mention CH4 is having dipole induced dipole force, that is 1 mark. The second thing you will mention, others have hydrogen bonds, that is second mark. And then you will compare hydrogen bonds are weaker as compared to dipole induced dipole forces are weaker compared to hydrogen bond, that will give you the third mark. And then you will compare, because they have the same number of electrons, they mention they are isoelectronic, number of electrons, so all have, even hydrogen bonding is there, and other than hydrogen bonding there will be London dispersion force or dipole induced dipole force with same strength. So they all have the same number of electrons, so they all have same dipole induced dipole forces, or dipole induced dipole forces will be of same strength. Then fluorine is the most electronegative element. Then nitrogen and oxygen, which is the most polar bond. But why H2O is having the highest boiling point? Because H2O or water has more hydrogen bonds. The number of hydrogen bond in H2O are more, compared to NH3 and HS. So that is the reason that we see that water is having the highest boiling point compared to other hydrides because it forms more hydrogen bond that leads to higher boiling point. Is it clear? Discussion. The next part, in question 4, which of the following statement about water is not due to hydrogen bond? So due to hydrogen bond, which statement is not due to hydrogen bond? Which of the statement? Water has less open structure than ice. That's true, and that is due to hydrogen bond because when they arrange themselves in a regular pattern. That's why the density of the water is less compared to density of ice is less as compared to density of water. So water has less open structure compared to that of ice, less open structure, and that is mainly due to hydrogen bond. Ice cube float, that is also because due to hydrogen bond, they arrange themselves in a regular pattern. The molecule move away, which reduces the density. That's true. When water freezes, its volume increase. That's also true because due to hydrogen bonding, they arrange themselves in a regular pattern and away from each other. What is a good solvent for ionic compound? That does not depend on hydrogen bond. That is due to the polarity, partial positive and negative. It can dissolve the substances. So D is the right statement. That does not depend on hydrogen bond. Rest other statements depending on hydrogen bonding. In question 5, the skeletal formula of three of the isomers are shown. Which series shows the correct order of increasing the boiling point? So when we check the number 1, 2, 3, 4, 5, 6. So this is having 6 carbon. 1, 2, 3, 4, 5, 6. So this will have 6 carbon. 1, 2, 3, 4, 5 and 6. So all have 6 carbon. But what about the branches? This is having one branch. This is having two branches. And this is having no branch. So the highest one is a straight chain which will have a large surface area. So increasing boiling point, so this will have low boiling point, lowest boiling point. This will have low boiling point because only one branch, and this will have the highest boiling point. So Y should be the highest and X should be the lowest. So D is the right answer for this question. Is it clear? Moving on to the next question. Explain with difference in intermolecular forces why the boiling temperature of alkanes increases as the number of the carbon increase. A detailed description of intermolecular forces. So, why as the now like example, if two carbon atoms are there in alkane and three carbon atoms are there, so increasing the number of the carbon atoms is increasing the boiling temperature. What is the reason for that? So first thing, they have induced dipole forces. That is one thing. Then these forces depends on number of electrons, so when number of carbon atoms increase, the number of electrons will increase. So more bonds are there or more energy is needed to break these intermolecular forces. That's why the boiling temperature increases as the number of the carbon increase. Next question. Which of these isomers with the formula C8H18 has the lowest boiling point? So to identify the lowest boiling point, we have to check the number of the branches, because in greater the number of the branches, greater the boiling point. So when we draw the structure of each, this is a branch, so two branches. This is having only one branch. This is having two here and one, so three branches. And this is a straight chain, so zero branch. So and we know the boiling temperature and the branches are inversely proportional. If we have more branches, the boiling temperature will be lower, so lowest will be C, will be the right answer for this. Which of these pure compounds has hydrogen bond in a liquid state? So carbon bonded with chlorine, it will have dipole forces. Here carbon bonded with nitrogen. If nitrogen bonded with hydrogen, then it will have hydrogen bond, so this will have dipole forces. Others will be there, but the major one is dipole. Hydrogen fluoride will have hydrogen bond because hydrogen bonded with most electronegative element, and this hydrogen sulfide will have dipole forces and dipole-induced dipole. So C will be the right answer for discussion. Because when hydrogen bond is there, when hydrogen bonded to most electronegative elements such as fluorine, nitrogen or oxygen. In question 9, the viscosity of four liquid organic compounds are compared by placing them in a separate identical tube, each with air tube bubble is there at the top. The tubes are inverted and the times measured for air bubble to travel. Which compound does the air bubble take the longest time? So how we can identify it? Because if greater intermolecular forces, so air bubble find it difficult to move through. So when we check the type of the forces, this will have hydrogen bond. This will have hydrogen bond. Other will be there, but the major I'm writing. This will have hydrogen bond. Why? Because hydrogen bonded with most electronegative, such as oxygen. And this carbon and oxygen, so it will have dipole forces. So three of them are hydrogen bond, and hydrogen bond is stronger. But which one will have the highest, greatest number of hydrogen bond? So C. Why? Because more hydrogen bond, so air bubble find it difficult to move through the structure, as it needs more energy to overcome the force of attraction between the molecules. Question 10. Hydrogen ion bonded to a water molecule by forming H3O ion. For H3O ion, what shape an HOH bond is predicted? So using electron pair repulsion theory. So when we use electron pair repulsion theory, this is a dative, like this is a structure of the water, two bond pair, two lone pair with a bond angle of 104.5 degrees. But now it is H3O, in which one of the bond is a dative bond. Like this bond is a dative bond and is one lone pair. So we have three bond pairs and we have one lone pair like ammonia when nitrogen forming a bond, three bond pair and one lone pair. So the structure is trigonal pyramidal with a bond angle of 107. If it is So using electron pair repulsion theory, we can identify the number of the bonds in a pair and number of lone pair. So you have to learn this, that if 3 bond pair and 1 lone pair, then the structure will be trigonal pyramidal. So C will be the right answer for this. In question 11, DMAA is only slightly soluble in water but dissolved readily in hydrochloric acid to form an aqueous solution. So it forms an aqueous solution readily dissolved in hydrochloric acid. Explain in terms of bonding that occur between nitrogen atom and hydrogen ion uh, when the positive ion form. So how we explain this? So which bond is formed between nitrogen and hydrogen? That is a dative bond is formed. Because nitrogen, when both of the electrons are shared by from one of the atom, we call that as a dative bond. A dative bond is formed between lone pair of nitrogen and hydrogen ion with no electron. So when you write this answer, 1 mark is for dative bond, 1 mark is that there is a lone pair on nitrogen, and the third mark is for uh, uh, hydrogen is not having any electron; it's a positive charge. Complete the diagram to show how the ions formed in the reaction between DMA and hydrochloric acid interact with water. So how these ions, which are formed like a positive and negative ion, they will interact with water. So when the water molecule, oxygen is more electronegative, so oxygen is partial negative, hydrogen is partial positive. So this will be partial negative, partial positive. And oxygen is attracted towards the positive ion. Oxygen partial negative from water molecule is attracted towards the positive ion. And for this one, partial positive, positive and negative. So negative ion hydrogens are attracted towards that negative ion because that is partial, positive in this water structure. Question 12. Which of the following molecule contain a polar bond but is a not a polar molecule? So bonds are polar. In which case bonds are polar? When a bond, a covalent bond is formed between the two atoms which are having a difference in the electronegativity, then the bond will be polar. Molecule can be polar, can be non-polar depending on the structure. So when we have a tetrahedral structure and identical bonds are here, a bond is formed between carbon and chlorine, so bond will be polar, but because it's a symmetrical structure, so molecule will be non-polar. In this case, bonds are not polar, non-polar. Hydrogen chloride's bonds are polar and molecule is also here. Bonds are polar as well as the molecule are also polar. But here bonds are polar like partial negative and positive, but overall molecule is a symmetrical. That's why it is a non-polar molecule. Next, which of the following has a dipole interaction between the molecule but no hydrogen bond? So this one, dipole interaction. The term dipole interaction means there should be permanent dipoles. So in CH4, it will have dipole induced dipole or London dispersion. So it cannot be a About B, it will have a hydrogen bond. I'm writing in short Hb. The third one also ammonia Hb. But hydrogen iodide, it will have dipole. Dipole, why? Because two different atoms are there, difference in electronegativity. So this will be partial negative and positive. So A will be the, so D will be the right answer. So question 14. Which list below shows a compound increasing boiling temperature? So CH4, it will have dipole induced dipole forces. So I'm writing Di. HCl will have dipole forces, and HF will have a hydrogen bond. So hydrogen bond is stronger, so highest boiling point will be HF, followed by HCl, and then the weakest will be CH4, which will have dipole induced dipole. So if the molecules are non-polar and the bonds are non-polar, then it will be dipole-induced dipole or London dispersion force. If bonds are polar as well as molecule is polar, in that case it will have dipole-dipole force. And hydrogen bond, when hydrogen forming a bond with most electronegative elements such as fluorine, oxygen and nitrogen, in that case it will be hydrogen bond. Question 15. Which of the following has a highest boiling point? So to have the highest boiling point, we have to check the number of atoms as well as the branch. Number of atoms should be high and the branches should be minimum. So pent means this will have 5 carbon atoms. This will have 5 carbon. This is having hex, so 6 carbon atoms. This is having 1, 2, 3, 4, 5 carbon atoms. And this is having 1, 2, 3, 4, 5, 6. So these two are 6 carbon atoms. So either B will be answer or D will be answer. But when we compare B with D, this is not having any branch, so we know that boiling temperature are inversely proportional to number of the branches. So this is having less branches or no branch, so boiling temperature will be higher, so B is the right answer. Is it clear, this question? Question 15. Then question 16. Use your knowledge of intermolecular forces to predict a compound with the highest boiling temperature. So how we can predict this? For ABC, all will have hydrogen bond. This HF will have hydrogen bond, H2O will have hydrogen bond, NH3 will have hydrogen bond, and this will have dipole-induced dipole or London dispersion. But because even though HF is more polar, but it does not form more hydrogen bond, greater number of hydrogen bond are formed by oxygen. That's why in H2O it will have the highest boiling point. And this is the same curve. You can check the table as well as it was there in question 3, that when we were comparing the boiling temperature, so you can clearly see that H2O is having the highest one. And why it is having the highest? Because it formed more bonds compared to more hydrogen bonds per molecule compared to others. Then question 17. Use your knowledge of intermolecular forces, predict which compound has a highest. So how we can work out which compound will have the highest? If you check the trend or the pattern in halides, so first it will be HF will have the highest, then HCl, then HBr, and then HI. Why? Because HF will have hydrogen bond, HCl will have dipole force, hydrogen bond, then HBr will have dipole induced dipole force, and that is higher. Why? Because it is having more electrons. And HI will have the highest. one in terms of this series, like lower than HF but higher than HBr and HCl, because that is forming dipole-induced dipole as there are more electrons. So same thing, if we have iodobutane and chlorobutane, this iodopropane, but they have branches, so branches cannot have the highest one. So when we check these two, then iodobutane will have the higher one. Why? Because it will have more dipole-induced dipole forces. There are dipole-dipole forces as the bonds are polar, but the number of the electrons are more in hydrogen iodide compared to hydrogen chloride. That's why it will have a highest boiling point in comparison. Question 18. Tetrachloromethane is, so when we check tetrachloromethane, it's the bonds will be polar. Why the bonds will be polar? Because the bonds are formed between two different atoms. That's why the bonds are polar. But what about the molecule? Molecule will be non-polar because it's a symmetrical. So polar bond with non-polar. It's a polar molecule. It's a non-polar molecule with polar bond. So C is the right answer for question 18. Then question 19, the difference in the boiling temperature between methane is CH4, and ethane, best explained by, because they have dipole-induced dipole force, and dipole-induced dipole forces increases as the number of electron or atom increase. So B is the right answer. Then question 20, ethanol is soluble in water, so it dissolves in water. The best explanation. So what is the best explanation why ethanol dissolve in water? Because ethanol will have OH and water is also having OH. They can interact and they can form hydrogen bonds with each other. So ethanol molecule form hydrogen bond with water molecule. That's the best explanation for to show that they are soluble. So these are the first 20 questions we discussed from intermolecular forces. In the next session, we will discuss more questions from this assignment. Any question related to the class today? Any doubt or a question?